Good morning, afternoon, or evening, depending on the part of the world that you're in. Welcome to today's webcast. I'm happy you could take a break from your jobs or whatever you're working on today to talk about breaking the cloud kill chain. Before we get started, I'll do a quick intro for myself. My name is Eric Johnson. I've been with SANS now for officially 10 years as of this month. And I started in our kind of application security curriculum doing secure coding courses. And over the years, I've been involved in authoring and teaching 5 or 6 different classes related to application security, DevOps, and a lot of cloud security topics as of late, which is why you're all here today to talk about some of the attacks and defenses in the cloud. When I'm not working with SANS or teaching or authoring courses, I'm a principal security engineer at Puma Security, where I focus a lot of my efforts on cloud security assessments, doing some penetration testing for cloud-hosted systems, and also building some automated security tooling in that space. My contact info is on the slide. Feel free to reach out to me about anything on the intro slide. I'll get into some of this stuff as we go. Let's take a quick look at our agenda for today. So the first topic, very short, is introducing you to the Cloud MITRE ATT&CK Framework, which is a really cool resource for understanding some of the new, more modern attacks against cloud infrastructure. And then we picked 3 of them for today. Ultimately, there's no reason that I picked these 3 outside of we've got 45 to 50 minutes along with some Q&A. So we'll, in that time window, be able to cover what I think are some of the 3 most common ways that we're seeing cloud infrastructure broken into from the outside. So we'll go through these 4 topics. If you have questions along the way, feel free to drop them into the Q&A panel in Zoom. I've got another monitor up where I can kind of see those questions come in. I often will address them in real time if it topically makes sense as we're walking through some of the sections and some of the slides. And if not, we'll hold off and we can kind of cover those at the end as well. So let's take a quick look. This is probably a little difficult to read on the screen, but if you go out to the MITRE ATT&CK Framework and look for the cloud-based techniques, that's really the area you want to focus on for defending your cloud infrastructure. It walks through what initial access looks like in a public cloud, which could be a public-facing application hosted in the cloud. It could be finding credentials to a valid account. It could be exploiting some third-party relationship where I compromise a vendor, and from that vendor, I can then pivot off into some organization's cloud environment. From there, we'll go through persistence and privilege escalation, and there's lots of defense evasion techniques that are very specific to the public cloud providers. And what this framework will walk you through are the techniques that you need to understand in order to do that attack as well as defend it. So it's a really cool resource for getting familiar with the public cloud providers, what resources you have to worry about from a misconfigurations perspective and from a putting it on the internet perspective, and then what attackers might do to try to establish persistence and exfiltrate data once something bad has already happened. In order to understand and do a lot of the techniques in there, it does require you to focus on some of the key services inside of your public cloud provider. At this point, I think the last statistic that I saw, Brandon Evans and Ken Hartman did a kind of a multi-cloud survey recently. And just in conversations with them a few weeks ago, they told me that over 50% of organizations these days are using all 3 of the cloud providers that you're seeing on the slide here. Many of them were also using some of the other cloud providers. So think of the Oracle Cloud or Alibaba and things of that nature. So what it's teaching us from a security perspective is that we really have to do a good job of understanding each of the individual services inside of these clouds, such as compute, storage, networking, key management, data protection, and some of the security as a service features. And not only one, but multiple clouds, and we have to understand the differences between these things. So I'll show you a lot of comparisons and these discussions that are coming up to say, hey, in AWS, you're looking for this, and in Azure, you're looking for that, and in Google Cloud, you're looking for this thing. And you kind of have to then go into the documentation and just read about the differences and compare and contrast the features between each of those items in order to fully grasp what that defensive technique might look like. So our first technique we'll jump into here is technique 1580. It's all about cloud infrastructure discovery. The short story here is something that you've probably seen in the news over and over and over again. It's essentially, we misconfigured a resource and we accidentally put it on the internet. So I'm sure many of you have seen lots of different news articles or breach notifications out there for organizations that have made a major mistake and accidentally put their storage account or their storage buckets on the internet. Can you think of a few of those off the top of your head? I highlighted a few just with logos on the slide. So Booz Allen, Dow Jones, Deeproot Analytics. There's a lot of organizations out there that have made this mistake. And when you're really looking at this, so the idea is we've got this storage bucket or this storage account. It's got tons and tons of data in it because a lot of people use these things as data lakes. In those data lakes, we sometimes need to share with other friends that are business partners or third parties or folks that maybe don't have internal access to things. And the thought was, you know what, really quickly, we'll just switch this access control list up and we'll open this up for public access. And then we'll call our business partner and we'll say, hey, can you go pull all that data down real quick that I just made available to you? Here's a link. Nobody else will find that, right? The idea is that, well, it's kind of a difficult link to guess, so nobody would ever locate that. And then ultimately what happens is we then forgot to change the access control list afterwards. So that data remained public. It's sitting out there on the internet, and there are some tools out there that will allow you to kind of enumerate these cloud resources, and it'll go in and it'll test, does this account exist? And it'll just guess by name those URLs, and eventually somebody will get a hit on that and you'll realize, oh no, we just dumped 800 million customer records out of one of these misconfigured resources, which is bigger than buckets, by the way. In Google's big query, we can make data sets and databases public. You can also go into an AWS container registry, a private registry, and you can make an image repo public. There's also just public registries in the clouds for you to push container images that might have systems or data, things like that into. You can make secrets, cryptographic keys public. You can also take snapshots of your databases and your virtual machines, and you can make those snapshots public, which can have a lot of customer information on them, which unfortunately can be really bad for an organization. And that's what we're dealing with this MITRE attack technique, is folks brute forcing names or trying to guess commonly chosen names for organizations and hoping that you have misconfigured some resources on it. Now, one of my favorite resources for what can we make public is maintained by Scott Piper, and it's a GitHub repo just called AWS Exposable Resources. And I love reading through this because every time I do it, it's just astonishing to me in the AWS ecosystem, how many different policies that you can write where you basically put principal star on it. And that will make that resource publicly available to anyone. So you can go through that resource, you can find the volume snapshots and the machine images and the container images, the queues, the Lambda functions, all of those sorts of resources that can be made public, which gives you a good idea for maybe what you need to worry about defending from a policy perspective as we shift gears and talk blue team here in a few minutes. On the Azure side, one thing to keep an eye out in Microsoft's cloud is a lot of resources don't really have that public setting on it. Azure storage accounts do, where you can make blob objects and containers public. but just about everything else is shared by creating a shared access signature or a SAS token. So if you go to a number of different resources and you go to kind of the settings in the permissions, you'll see a screen like this that might say, oh, if you want to share this VM snapshot with another subscription or another customer inside of the ecosystem, how do you do it? Well, you just click this generate URL button and it creates a one-time token. There is a little bit of a defense here, which is, well, how long is this link valid for? So you can make this expire, but it's important to realize that generating those SAS tokens opens up a window of opportunity where somebody could guess that, or I could post it in our Zoom chat here, and then everyone with that link could download that VM snapshot. So it's more important to probably monitor for the creation of those SAS tokens to see if folks are creating these tokens on resources that maybe we don't really want to be public. And then we can look at inventorying those and trying to figure out how can we block that from a policy perspective in the resource hierarchy, which we'll get to here in just a moment. So the way that we can monitor and then defend starts with policy. I know it's shocking, right? So if you're looking at all the audit logs of here's the SAS tokens, here are my offending public resources, and you're seeing the different types of resources that are being made public throughout a massive enterprise cloud, what you then need to do is go back into your resource hierarchy and learn to love service control policies in AWS, Azure policy in the Azure ecosystem, as well as organization policies in Google Cloud. These are top-level policies that you can write that can pretty much prevent misconfigurations from happening. I know all the buzz right now is, the cloud security posture management tools, the CSPMs, the WizIOs, and the Orca securities, because they're doing a great job of going in and finding misconfigurations, and they give you a dashboard to go identify those things, which is cool. So pretend you've got this big data set, and sure, you can remediate the bucket that's on the internet, and it'll drop off of that CSPM dashboard. But the bigger question is, how can we stop this from happening in the future? How do we put guardrails in place to prevent that? And these policies allow you to do just that. So the idea here is that in your hierarchy, now this is an AWS hierarchy, which is where you have a management account at the top level. So that's your organization's account, and that's your root node. And then underneath that account, you can create a hierarchy of organizational units as well as accounts. And on each of those nested resources, the OUs and the accounts, you can attach policies that say, here's a list of things that cannot be done underneath this particular attachment point. Now, in the Azure world, it's very similar. You've got a root level management group, you've got sub management groups, you've got subscriptions and resource groups. All of those can be used to attach Azure policy. In the Google Cloud, you've got a folder structure with projects underneath it. And all of those essentially create the same sort of hierarchy that you can go through and start to apply policies at the top level. So as we take a look at just a couple of example policies, let's pretend that Cloud Security Posture Management tool shows you that you've got a public S3 bucket on the internet. You can go into the S3 control settings for that account. And really, you should probably have a control tower setting or, a Terraform module that in every single account enables the public block access setting for the entire account. And that effectively just gets rid of the entire capability to make a bucket public. Also, recently, AWS has started to just prevent public bucket settings from being created by default. So even if you try to add an ACL to do it, it's not going to work unless you change the public access block settings on that individual bucket. So the idea here now, which is great, is going forward after all the problems we've had, The S3 buckets are secured out of the box from public misconfigurations. And all you need to worry about is somebody purposely changing that to be public. If you drop in a service control policy, like we're seeing on the left-hand part of this slide. So let me zoom in on this a little bit just to make sure you're understanding which policy we're talking about here. On the top of the hierarchy, maybe right there on that kind of root OU for any account that contains data in S3, what you're going to do is add an S3 put account public block access restriction in place. And we're going to say this affects all resources underneath this attachment point of the hierarchy if somebody tries to change that public access block setting to allow a bucket to expose resources publicly. Do we all see the effect there on line 8? Yeah, we're going to block that API call. So we can no longer, if this policy is covering the whole organization, make data public through an S3 bucket. And that effectively breaks at least that attack path through the kill chain. Let's take a look at just a slightly more complex one. I mentioned earlier that functions, so Lambda functions, can also be made public. And the idea here is that we do not want Lambda function URLs to be able to expose functions to the internet so anyone with the URL on the internet can invoke it. And that is a couple of different actions. There's a create function URL and an update function URL configuration action that we need to worry about. And we're going to say all Lambda functions, we're going to deny the creation for that if the auth type is not AWS IAM. So essentially what we're saying is if it's an anonymous URL, we're going to block that. At the bare minimum, in order to create a function URL, we have to be authenticating with valid AWS IAM credentials. So that's a slightly more complicated policy. You'll notice the resources, we've got that scoped to all of the Lambda functions in the hierarchy underneath me. And then the condition goes through and uses some condition keys in IAM, and it says, okay, we know that we've got this metadata, this function URL auth type available. Let's filter it down to just that. Alternatively, if you just wanted to block all calls to create function URL config or update, you could do that. And then you could say, well, if we're going to have to hit one of these from the outside world, you need to come in through a load balancer or an API gateway or some sort of more full-featured security appliance in order to get to the function. That way we've got a choke point out in front of the function rather than hitting it directly. So those are just a couple of examples of different policies that you can add into your hierarchy to prevent resources from being publicly exposed on the internet. So kill chain topic number 1 complete. Just going to check the QA and make sure that nobody's dropped any questions related to that topic in there. Looks like we're good up to this point. If you're an attacker, that was kind of the easy path for a while. Nothing is available anonymously, which honestly there shouldn't be unless it's public information and we don't care. So if you're trying to attack some customer's cloud and you cannot find any public resources out there on the internet, your next move or your next pivot in the kill chain is to try to find credentials that will allow you to authenticate to the cloud and invoke an API using valid credentials. So this is your next step. The big question is, well, what are the credentials and where can I find them? They vary quite a bit. The credentials between the clouds are a little bit different between AWS, Azure, and Google Cloud. Typically, you will find those credentials. Now, these could be long-lived credentials that do not expire, they do not rotate automatically. The cloud IAM admins have to go in and rotate these things and update them periodically. Or they might be short-lived kind of OAuth tokens or temporary session tokens, things like that. So you have to understand which ones you're dealing with. And then you can start to invoke the cloud provider APIs when you discover them. Common locations, most of us probably think of checking these into GitHub and accidentally putting them in a public repo specifically. And then, oh, in GitHub, I found this customer's, Google Cloud Service account key file, and now I can talk to the Google Cloud as them. And that is something that happens frequently. The cloud providers have gotten much better about locating those sorts of accidents, we'll call them, in GitHub specifically, or GitLab, and telling the cloud provider, you need to revoke these creds because we've got a big problem here. So source code is one that we probably always think of first. However, as you start to dig around, especially on running systems, you can find a lot of credentials in just local configuration files. So think of a developer's workstation. If you get malware onto an engineer's laptop, there's some places that you should be looking for credentials on that machine. Version control history is another one. If I accidentally checked in credentials to version control at one point, and then I thought to myself, that's a terrible idea. Let me delete those 5 lines and we'll move that credential somewhere else. You have to rotate the credential because it's easy to scrub the history of version control. And we'll take a quick look at a tool that can help you do that here in a moment. Bash history, just export AWS access key and secret key and session token equals value. You can find that in the bash history. If you're running on an actual instance itself, you're looking at environment variables will have lots of tokens, as well as the metadata services that are available for getting temporary credentials mapped to the role or the service account that your VM is running as. So these are all places that you should be looking. And over the years, we've discovered a lot of different long-lived credentials that are mapped to the different clouds. So if you're in the AWS ecosystem, a long-lived credential is going to be basically some access keys attached to an IAM user. If you're in Azure's cloud, you create an app registration, which creates a service principal. And then the service principal is something that will have a credential attached to it. And that credential will essentially have just a client ID and a client secret value. And then in Google Cloud, you're looking at service accounts all the way around. And you can create long-lived service account keys, which are just kind of public-private key pairs. And those will give you access directly to a service account. You can authenticate as that service account. So those are the sorts of things that you are looking for if you're an attacker. Now, Team TNT has been around for a while, and they've got a lot of different malware samples that are out there. And lately, over the last few years, we've seen some cloud-focused malware come out. And it's looking specifically, so if we can run the malware, let's just say on a developer's workstation, it's probably looking in these locations, because if you've got the AWS, the Azure, or the Google Cloud command line interfaces installed, you are going to end up with credentials in a credentials file, potentially, access tokens in an access tokens JSON file, or credentials in the config gcloud directory. And those may be long-lived, they might be short-lived with an expiration, but I'm showing you just a chunk of an access token in my Azure access tokens JSON file, which you'll notice it does have an expiration on it, which is good. But if that malware finds an active one, that can immediately be turned around and used to authenticate to that cloud. So those are the kind of the local credential file locations that sort of malware is looking for. If you look at source code, now this is a really interesting comparison. And 2 independent researchers did this within a couple of years of each other. But I mentioned version control, and even if you build an actual application and you bundle it up and you put it in a package manager so that artifact is ready to be deployed, essentially, we know that this is a problem. And what Aidan Steele did back in October of 2021 is he scanned all of the node package manager npm. We scan all of npm and just basically pull every package down, open it up, run some basic greps through the code for identifiers that will help you locate some of the AWS access keys. And what Aidan did was just inventory. Here's all the valid keys. I'm going to make a quick call out to the cloud, make sure it's valid. Nothing, that would change or modify anything, but let's just test to see if this credential is still active. And scanning all of NPM, 117 different API keys were identified in the node package manager, and 30 of them happen to belong to the root user. So that's a really big deal, because that AWS account is essentially just completely owned if we've got access to the root user accounts. So somebody asked out in the Q&A, is there open source tools for identifying these unsecured credentials? So if you go to the links at the bottom of this slide, you'll see the different regular expressions that Aiden and Tom also used to make sure that we can locate those credentials. So you can write some custom greps to do this. There's also a couple of open source kind of secret scanners out there. It depends on the ecosystem that you're in. But this has been such a big problem that AWS has also open sourced a tool called Get Secrets. So if you go to GitHub and just search for Get-Secrets, you'll find a secret scanning tool that will go through, your Git commits and your Git history and things like that. And it'll tell you, here's some access keys that I located. A lot of different just static analysis tools in general will also have rules for identifying secrets in source code. So that's another way to do it. And had anybody run any of these against those package managers, as we pushed them up to the repo, we wouldn't have had the data end up in the actual package manager itself. Now, Tom's research is relatively recent, right? So this is just a couple of months ago, and it identified 57 AWS keys, so a little bit less than NPM, with 11 root access keys over in the Python package index. So we know that they exist. So if you're using a package manager, even if it's private, this is another place that you should be looking, because the attackers are going to be looking there as well for valid access keys to cloud environments. Environment variables, another very popular location for storing credentials. Even AWS themselves, in some cases, this is a dump of environment variables from a Lambda function. In a lot of cases, AWS will just store the credentials. If you've attached a Lambda execution role to the function, you're going to find a session token, an access key, and a secret access key ID value on the function's kind of runtime in the environment variables, which, if you've got command injection or some sort of local file inclusion vulnerability in that source code, people can exfiltrate these values from the function, and then you can use them to authenticate to that cloud environment. Now, this isn't unique to AWS. Other developers that I've worked with will often put secrets in environment variables, which can include service account keys or client ID, client secrets, and things like that. So environment variables are a very popular place to look for credentials that can help you pivot into other clouds. So as we pause and look at the blue team side of this a little bit, really what you're defending against here is just credential theft. And it starts by not putting them in version control. So let's do some secret scanning, which will kind of go back to that question that came up in the Q&A a few minutes ago. Let's also look at, can we kind of detect compromised credentials? And then the real true solution is getting rid of kind of long-lived credentials in general. So we'll take a quick look at what workload identity federation is, and then we'll wrap up our Techniques 1522 discussion here. So here's another tool that can help you. Now, this is not technically open source. So the Q&A question asked specifically, I think, for open source secret scanners. GitGuardian can be a paid service, but it has a freemium tier on it. And I really enjoy GitGuardian in general. So we use GitGuardian internally at Puma Security to help us discover secrets in version control. And you can do this a couple different ways. So you can go to the GitGuardian UI and you kind of register your organization. You can connect it to your GitHub and your GitLab orgs, etc. And then Git Guardian will just continuously scrub your commits in your history for secrets, and it will just notify you, hey, Eric, I found something. Now, this is kind of a funny story that just came up this week, actually. So Git Guardian knows basically my GitHub user ID, and it knows all the commits I've made under the different accounts or email addresses. And what happened was I got an email. I believe it was Friday night or something like that. And on Friday night, it said, hey, Eric, a Slack webhook was discovered in this other repository. So it was a completely different GitHub owner, completely different repo, but it had my commit ID on it. And I said, well, that's kind of crazy. How did that happen? And so I looked in the repo, the public repo that had identified my commit in with a Slack webhook, which for those of you that haven't used webhooks in Slack before, it's just a URL that allows you to send automated messages to a Slack channel for notifications like, hey, this build failed or something like that. So I got this notification. Git Guardian says you have what looks like a Slack webhook that belongs to you over in this other repo. And ultimately what happened is in some of our labs for our courses, we have them on a virtual machine and the students can use them and go play around with things. And in this case, it was sending an automated Slack message. And what happened is one of the students said it wanted to practice using kind of a Git remote add feature, which took the code from the VM and pushed it into their own GitHub organization in a public repository. So that's how the code went from me to a virtual machine off into a different GitHub account. And Git Guardian was smart enough to look in the Git history, find the author of that specific commit, which is somewhere else in the entire ecosystem, and then notify me that that had happened. And we went in and double checked, and it turned out the Slack webhook was completely, invalid. We had killed it off years and years and years ago and rotated it. So it wasn't really any sort of an incident or an issue, but it's really cool to know that this tool is watching for things like that. Alternatively, you can use GitHub has some built-in secret scanning alerts. So the right side of the slide, I'm showing you just GitHub itself saying, Eric, it looks like there's 23 different secrets inside of this repository. The limitation there is that depending on what GitHub account you have, if it's a public repo, you can just use this. If it's a private repo, you're going to have to be kind of in an enterprise, and you're going to have kind of the advanced security offerings in order to get some of these secret scanning alerts on it. But those are two more examples of how you can look at preventing secrets from ending up inside of a repo or from somebody finding a valid one that still actually allows you access into a cloud. As we take a look at the threat detection capabilities, this is something that has been, let's just say, a lot of research has gone into how to make this better over the years. We've realized that credentials are everywhere, and those credentials can be used by an attacker. So in the AWS ecosystem, we've seen some cool guard duty categories or searches essentially show up, looking for just random credential behavior. So you'll see there's an IAM user that's making kind of, they call it anomalous behavior. And that's something like, okay, Eric's usually, at my home office or on this, private network making connections, but then that same credential jumps off over to an IP address over in Tokyo, for example. And that's weird, right? That shouldn't happen. So it's looking for different anomalies like that. Other things that they're looking for are instance credential extraction. So that would be me compromising an EC2 instance and then using the metadata service to grab temporary credentials. And then if I use that from another AWS account or from outside of AWS, that is an issue that we should be researching or looking into. I'm going to post a message in the Zoom chat for you as well. There's been something they've added very recently So I just posted that blog out there, and I think, oh, maybe I need to switch this to everyone. Give me 1 sec here. We'll try again. Okay, so you should see that link now. Let me know if you didn't. But this new feature at AWS is released just a couple of weeks ago, and it's now a policy that says credentials on a VM can only be used from the VM. You cannot actually take the credentials and use them from anywhere else. So that's a major update to preventing kind of the credential extraction off of an AWS hosted VM. I'm hoping they keep going with this, because if they add this to other resources like container services and Lambda functions and, like code build jobs and things like that, we've done an amazing job of preventing this from even happening. The last piece that you need to be aware of from an incident response perspective is how to revoke stolen credentials. So in a lot of cases, AWS and the other cloud providers, they create these credentials and there's not really an expiration on them. So if you're looking at guard duty and one of these alerts pops up, what you've got to do is go to the role or go to the IAM user, and you need to actually invalidate the credential, because otherwise they can just keep using it over and over again. So if you look on the screen here, what I'm showing you is from an IR perspective, you've got to go in and revoke active sessions. And what you can do is go in, and the only way to do this really is say deny ** everything that's gone on with this particular role or user if the date of the token was issued prior to right now. So you're basically just shutting access off for everybody else that might be using that token in a valid context. But that's the only way to do it. Everybody's got to grab a new token, refresh it. All the older ones are invalidated. Yeah, great question. So does Azure have a restriction? And I'm going to throw Google in there too. Do either of the other clouds have a restriction where credentials can be used from? And unfortunately, that answer is no. And trust me, I've done a ton of credential extraction and attacking over the years from EC2 instances, from Google Cloud Functions, from Azure Functions, from Azure and Google VMs. Never, ever, ever have I run into a problem where the cloud provider has even told me that that activity was going on. AWS, and I suspect largely it's because of the publicity that the Capital One breach got, which is kind of what happened in that scenario. Most of the effort here, restricting where they can be used from, and these cloud native threat detection capabilities, most of this research and R&D is coming from the publicity from that breach. And that hasn't been as big of an issue, at least publicly, in those other two clouds. So I am not aware of one. If you know of some, whether it's threat detection or whether it's an actual limitation to say we can lock creds to this one machine, please let me know. But I have not seen anything like that that allows you to do that. Yeah, it looks like Belinda posted a conditional access control policy. I'd have to look at that to see if that's doing exactly what we're wanting that to do. Maybe they are starting to build some of that in there. It'd be worth checking out. One thing I will tell you, if you have not started scraping your logs for this sort of activity, right? This is you making up for these gaps in the cloud provider. So what you really need to be doing is identifying what normal looks like in your cloud audit logs. So this is a Google audit log that we're checking out now. But the idea here is, okay, you've got some sort of an instance or a cloud function running internally inside of a VPC, for example. So it should be on a private network, like a 10.42.0.35 or whatever. And that credential, if you look on line 4, is always going to be used by this service account. So you know the service account, you also know the normal location, and then pretend this record drops down into your audit logs. And suddenly as you look at this, you're saying, okay, the Cheetah service account is accessing a secret, which is normal, but why is it accessing that secret from a public IP address on the internet, not from my internal VPC, or a public IP address that is owned by your organization inside of that cloud. There is an anomaly there. And your threat hunters are going to have to start writing queries against whatever your SIEM solution is that's digesting all of your cloud audit logs to attempt to identify this sort of activity. So there's a lot of work to do here in order to identify this and make up for the fact that you can still steal a lot of these credentials from different sorts of resources in the clouds. Now, the real solution here, and this is a plug, I've got an RSA session coming up in, it's about a month. So at RSA 23, it's in San Francisco, I'm doing a full hour session basically on this slide. And what we're going to do is look at the long-lived credential killing options that are inside of the different clouds. Because at this point, there's no reason to create a long-lived service account key, an access token, or a client ID secret in Azure, or an access key in AWS, because all the clouds have great support for federated identity. So using some external identity provider, which there are many, many, many of them, between GitHub, GitLab, your on-prem kind of identity server, Azure AD, Amazon Cognito, the HashiCorp Vault, you name it, all of those can issue a JSON web token or a SAML assertion, and you can use those to authenticate temporarily into a cloud provider and then access resources. And that credential doesn't need to be stored anywhere. You just use it, throw it away when you're done, and then if you need to access things again, you just make that exchange all over again. So I won't dig into this too much, but if you're looking at the clouds, what you're really wanting to research is the identity provider in AWS, workload identity federation inside of Azure and Google Cloud, and that allows you to just destroy long-lived credentials altogether. So that's our second topic. We've got one to go, and I think we're going to be okay time-wise there. So another question came in that said, okay, we've got SCPs to prevent misconfigurations. Is there some other kind of control to look at some of these sensitive or critical anomalies, which kind of goes back to that slide that I mentioned? Not really. Guard duty and some of the threat detection services. So if you go into Google's Security Command Center and you enable the kind of next level premium offerings for workload protection, and if you go into Azure, security, I would say Security Center, but Defender for Cloud now, if you do their workload protection capabilities and turn it on for containers and VMs and all that stuff, that's about as good as you're going to get from a built-in native threat detection capability, but they're not going to find everything. So the real solution, and you need this no matter what you're using, is for you to identify and do some threat hunting using queries like I showed you before. All right, so we've got about 15 minutes. We'll try to hit this one in like 10 minutes or so. So you've got a few minutes for questions at the end. Our third topic is network service discovery. So we've blocked public access. I can't just connect to things, which is good. I now hopefully have eliminated all of the long-lived credentials that are maybe exposing my organization to our second topic. So now, if I can't connect to the management control plane API using valid creds, what I'm really looking for are resources that you have made public on the internet. And hopefully through a more traditional network attack vector, I can find a public VM on the internet, some sort of VPC bound resource, and then I can leverage some vulnerability in that system to get into your cloud environment, and then I can laterally move from there. Now, the short story here is I'm just going to push you towards a presentation that Josh Wright gave. And this was back in January, if I'm remembering correctly. The link is on the slide here. What I would highly recommend you do, Josh did a whole hour on just scanning the cloud kind of at scale using mass scan, looking for the cloud provider's well-known public IP address blocks, and then pumping all of those resources into vulnerability scanners that can help you identify basically remotely exploitable hosts, services, and software that are running on some of these VMs. So that, in my opinion, is where you should go if you just want to learn how to do this. And what you will need to understand is that most of the cloud providers are opting you into putting things on the internet. If you go through the web UIs for AWS, for Azure, or for Google, it is literally going to walk you through, I'm going to create a VM for you. And out of the box, I'm going to open up the administrative ports for SSH or RDP to the outside world. And unless you do something to stop it, like say no on the screen, that is going to essentially put your VM on the internet. So that's an issue. You need to do something to prevent that. Now, Google is also something that is concerning. If you look at the way that Google sets up their VPC networks in Google are auto-created, the default, and they have auto-populated firewall rules that just get pushed into the project as you spin this thing up. So if you take a look at this rule list, let's check this thing out. Does everybody see the ports that are just out of the box open there? Oh, that video must have gotten moved. We can dig it up for you. We'll fix that link. So out of the box in Google, any VM that you create is going to basically say, okay, SSH is open, RDP is open, and ultimately what that ends up causing. So now you go out to Shodan, right? Let's just search for all of the VMs that are publicly accessible on the internet from Google's IP range. And are you seeing the results here? This is a couple of years old, so I suspect it's much higher now. But take a look at how many VMs are just publicly accessible on the internet. That's essentially what Josh is helping you enumerate in that video. So we'll find it. I think it's probably on the Offensive Ops YouTube channel would be my guess somewhere. So we'll get that link directly over to you here in a moment. But 1.7 million VMs are on the internet. Most of the time, as you're looking at architecture, the reason that they're on the internet is not because they needed to be, it's because the cloud provider opted you into putting it on the internet when we just clicked our way through the wizard. So the real defensive technique here is bring your network engineers in and let's do a better job of actually architecting private networks in the cloud and then publicly exposing things only when we have to. So if you go into the network design documents for any of the clouds, essentially they're going to push you into using a shared VPC architecture in some sort of a network hub and spoke model to centralize ingress, centralize egress, and set up inspection firewalls inside of your network. And what that will allow you to do is create public entry points, but also you've got firewall inspections to help you prevent reaching those resources if the traffic's not coming from a trusted location or different times of the day and so on and so forth, similar to what you would do kind of in an on-premise network setup. Let's see, someone says, trying to create the Azure VM having a public IP, but Azure policy doesn't have a property to block it. I'm pretty sure I've seen that done. I would need to dig it up. So let's see if we've got time after this and I can give you an idea of the property that I queried on. I'm not positive if it still works or not, but yeah, we'll circle back to that one. But that's exactly what I'd be looking for. Prevent the public IP from being attached or created on the VM. Let's take a quick look at shared VPC. So this is something I want you to understand. A lot of times networks end up being built by very, decentralized teams in the cloud, because you're going to hand dev team 1 a subscription, dev team 2 a subscription and say, go build your VNet in there. And ultimately, you don't really want that. You want your network team to be in control of all this stuff, but you want the dev teams to be able to launch resources into it. And the problem with the dev teams launching resources inside of the network infrastructure account is that they now have permissions to the network infrastructure account. So what AWS and Google did, which is a really cool feature, is gave you the ability to create a network host project or a network host account. And that host account is going to have the network admins in it. They're in charge of all things networking related. So they're going to build the VPCs, they're going to build the subnets, the internet NAT gateways, the routing, the firewall rules, etc. They're in charge of all that stuff. When they're all done, what you're able to do in AWS and Google is say, this one subnet, this private subnet, I am going to share with a development team's account or project. And when the development team logs into their account, they're going to see that subnet there, and they can launch their EC2 instances into it, but they have no control over the configuration and the routing inside of the subnet. So it's a way to separate that responsibility and say the network team is in charge of all of the things that they should be, and then the dev teams over in some other siloed account can go use it without having to give them permissions to manage any of the VPCs or anything like that. So it's a really nice way to separate responsibility and architect your cloud so all of the different hosts are inside of one centralized account, the network hosts, that is. And then going into your policy hierarchy, like we looked at earlier, we then create a policy that says, here's a list of actions that can create public connectivity. So that would be allocating in a public IP address, attaching or creating an internet gateway, creating VPC peers or connections. You just list all of these actions and say, this cannot be done from any account in the entire organization except for the dedicated network host account. So you've now prevented any of the engineers, the development teams from accidentally creating a VM with a public IP address on it in their own account because it has to be approved by the network team. The other part it really helps me with is inventory. Now, if I need to go look at where do I have public IPs, I know it's all in one location. So this is where I would jump in here and say, let's go look in the network host account. Let's go look at the network interfaces. And we'll say, all right, there are 12 public IP addresses in this org. These are the load balancers and the NAT gateways that they're attached to. And you've got them all in one location, that single pane of glass you would want if something comes up or you need to look at malicious activity on one of them. From there, now that you've got all of your network resources centralized, what you're ultimately looking for, and this is something that I'll show you an official slide here in a moment. I'm doing a demo on Thursday morning, and the exact time is on the slide coming up in our SANS Cloud Security Discord channel. In that session, what I'm going to do is walk through this architecture I'm showing you on the slide. So it'll be AWS specific, but you can do it in the other two clouds, essentially setting up a hub and spoke model. So you're going to have a centralized ingress VPC where all of your public IPs are coming in through that public subnet, an external load balancer going into a hub, which in this case is the transit gateway. The transit gateway is going to send all traffic to a firewall and a dedicated security account to an inspection policy list. And if the traffic is allowed, it will then be forwarded back into a private network where the EC2 instance or the container service is actually running. It also centralizes all outbound traffic into a centralized egress VPC, which again, you can set up FQDN filters to restrict which domains all of these instances in the big global network are allowed to talk to. So it's a next level kind of enterprise network. We'll spend 30 to 40 minutes with just live Q&A and questions in the Discord channel this Thursday. So if you're available and you're really interested in this, make sure to jump in there and check out that demo. All right, so we've got about 5 minutes left till the top of the hour. Just a couple of conclusion slides here. The cloud is fun, and it's also very challenging to work in. And as you go to multiple clouds, understanding how things can be made public or what the credentials look like or how things are exposed to the internet, it requires a lot of dedication to different services, configurations, and just nonstop research. It will keep you busy for a very long time. There's a reason that there are tons and tons of jobs open in this space right now, because we just need more people that can help build and defend these environments. So take the opportunity to learn about the kill chain, learn about the defenses. SANS has a massive cloud security curriculum at this point that has grown rapidly over the last couple of years, very much thanks to Laura, who's on the webcast with us today, as well as Frank and Dennis Scandrette. So kudos to them for putting together the curriculum, the roadmap, and all of the other fun stuff that we've got available for you, and especially free resources. There's tons of webcasts like this and posters that you can go check out to learn about all of these different kind of touch points that you need to becoming, as we would say, a cloud security ace. Here's your Discord slide. So if you're interested in that centralized network that I was going to kind of show you the diagram on a couple slides back, if you're interested in the live demo, and I'll walk you through some of the configurations and we'll check out how the routes work and things like that, jump into this. That is at same time on Thursday. So 2 days from now, throw that on your calendar and we will kind of just explore and have fun there. So that might be the beginning of what we're calling a demo Thursday or demo Friday, where we can just show off some cool lab environment things that we've got built. If you loved the comparisons between the clouds, what I would love to see is some of you jump in and take our SEC510 course. That is all about public cloud security and AWS, Azure, and GCP. So that is running in Orlando at the beginning of April. It's live online also in mid-May, and it's also out in San Diego, early May for live online, San Diego mid-May. So that's going to be a course that you can really learn some of the differences between AWS, Azure, and GCP to kind of take your cloud skilling up to the next level. So reach out to me or Brandon Evans or Ken Hartman if you've got questions about that course. We'd love to get you in there, and you can race for the challenge coin that you're seeing on the slide. All right, with that, we've got a couple minutes for Q&A. I've got a couple other questions in there. So whoever asked about the public IP in Azure, here's what I'm going to do. Reach out to me in the Discord channel. Just shoot me a direct message in there, and I'll send you at least a snippet of what we have used in the past to try and block those public IPs, and then let's go from there. So if you can just find me in Discord, that's probably the easiest way to continue that conversation. Let's see, Ken asked, the big three cloud providers, are they similar enough that generalization is viable, or is specializing, in one or more of them a realistic path? It's a tough question to answer. I'd say it's a little bit of both. Now, generally, they all do the same things. And generally, you've got a VM service, you've got a network service. The terminology is a little bit different. So I think from just being able to operate in one of those clouds, having general knowledge is enough to kind of get your feet wet and figure things out. From doing it, I didn't understand all three of these clouds until I dug in and actually started researching the differences between them. The specialization side comes from knowing kind of what the defaults are in each cloud. When you click through the web UI, or when you just create a resource, knowing that, for example, in Google and in Azure, your storage account is using kind of cloud managed keys out of the box. And then in AWS, up until very recently, there was no encryption on an S3 bucket. So knowing what the defaults are and then knowing the configuration switches to change on them in order to harden the environment, that's where the specialization really comes in. And leading into the next question, that's what SEC510 is all about. SEC510 talks through all of those key services, all the differences in them, and tells you what you need to know to be able to jump in a specialized manner and start defending those environments from a kind of a GRC, kind of a compliance perspective. SEC588, going to the back half of that question, doesn't really cover defenses at all, or even the misconfigurations inside of it. It's really all about just attacking the cloud. So think of the MITRE attack techniques I walk you through. You'll go do that stuff, but you're not going to do the blue team portion. So hopefully that gives you some info. Again, you can reach out to us on Discord. There's channels for each of the courses in there if you've got other questions you want to drop in. And the TAs and the authors are in there periodically to answer things. So with that, we've hit the top of the hour. Thank you all for attending. Hopefully you got some good info out of this, and I look forward to seeing you on our next broadcast.